Alright, so that would be 9 times 1.2 times 10 to the 4th per, and this is grams, right, because we still have the G there, per year. So now we have grams per year, and we can multiply this out. 9 times 1.2 is going to be 10.8. Is that right? Yeah. Times 10 to the 4th. Grams per year. And so they want to know how many kilograms per year. Okay. So, first of all, they always want this to be in form where there's only one number before the decimal. So let's convert that to that. So that would be 1.08 times 10 to the 4th grams per year. Now we want this to be in kilograms. So what we can do is we want grams to go away, and so we'll have 1 kilogram, but there is 1,000 grams in a kilogram, because back up here we have kilo, which is 1,000. So there's 1,000 grams, 1,000 of the grams in 1 kilogram. So 1,000 grams in a kilogram. We'll divide that by 1,000, so 1,000 is 10 to the 3, so we can just subtract 3 off of this, so it would be 1.08 times 10 to the 1, which would be, and then we can just round this, since the smallest amount of significant figures is 1, so we can round this to one significant figure, which is 1 times 10 to the 1. So yeah, 9 grams times this give us how much CO2 per year. So that's how many grams. And then to get to kilograms, we divide by 1,000 here, and we get basically 1 times 10 to the 1, which is 10. Roughly. So roughly 10 kilograms a year each person is emitting, which is not that much, 10 kilograms. It's not a whole lot. Alright, so that's it, and this is going to be in kilograms per year, per car. And always make sure to, you do the units correctly at the end. And since it was per car. Alright, problem number 3. The total aluminum consumption in the USA in 2014 was 5 megatons. So total aluminum in the USA was 5 megatons. Alright. Mega, we know up here is million, so that's basically saying 5 million tons. Or 5, let's just write this, 5 times 10 to the 6th, right? Mega is 10 to the 6th, so 5 times 10 to the 6th tons. Okay, 5 megatons. How many kilograms of aluminum per person does this translate to? So now we're talking about the entire USA is 5 megatons. Now we want to know how many kilograms per person. So we need to convert this to kilograms, and we need to convert it to individual person, because this is like per everyone. So here they give us how many people, the population is 3 times 10 to the 8th, and a metric ton is 10 to the 3rd kilograms. So use exponential notation, of course. So first let's convert this tons. We already converted from megatons to tons just by using this quick chart. So now we need to convert this to kilograms. So we want to get rid of tons. So how many kilograms per ton? Here we have 10 to the 3rd. So 10 to the 3rd kilogram. So we're multiplying 5 times 10 to the 6th times 10 to the 3rd, and we just add these exponents here. So that's going to be 5 times 10 to the 9th kilograms. Tons are gone. And this is how many kilograms we have. But this is per the entire USA population. So now we want to get it per person. So we want kilograms per person, right? That's what they want. They want here how many kilograms of aluminum per person does this translate to. So we want kilograms per person. So to get kilograms per person, we just do kilograms divided by people. And people is 3 times 10 to the 8th here. And so to do this, what we can do is when we are dividing like this, we subtract the exponents. So we can do 5. So basically this is 5 divided by 3. And then 10 to the 9th minus 10 to the 8th is just 10 to the 1st times 10 to the 1. So this is 5/3 times 10 to the 1, which if you plug that in a calculator, you should get 16, which equals like, if you plug that into a calculator, it would have been 16.66. But we want one significant figure, because this is one significant figure there, that 5. So, and we also want it to be an exponential notation, of course. So this would round to 2 times 10 to the 1. So this would be 1.666 times 10 to the 1. Because 10 to the 1 means there's one extra 0, so we move the thing over 1 here, so it would be 16, which is what we have. But we're going to round this up to 2 times 10 to the 1. So that is our answer, and don't forget the units, kilograms per person. Make sure that this lines up with what they say here. They want, it says how many kilograms aluminum per person does this translate to, so we can write kilograms aluminum per person. And that is our answer. Alright, next problem. Numero 4, quattro. Alright. A common amoeba is about 500 micrometers. Micro is this weird little U here, micro, which is 10 to the negative 6, and you probably can't see that, 10 to the negative 6 for micro. So first of all, let's translate this problem as we go. I mean, reading through a whole problem can get daunting, so what you do is you find something and you write that down. You're like, oh, micrometers, 500 micrometers, I know what that means. That means 500 times 10 to the negative 6 meters, right? Because meter is this, and to get to micro, it's 10 to the negative 6. Right here. So it's 10 to the negative 6 meters, full meters. We got rid of the micro, and we replaced micro with 10 to the negative 6, right? Because micro is 10 to the negative 6. So we replace micro with 10 to the negative 6. So 500 times 10 to the negative 6 meters. Okay, per amoeba here. How many amoebas, end to end, would it take to make a chain stretching from blah 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 to blah 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 Ann Arbor? Distance equals 10 kilometers. So basically what they're saying is that how many of these does it take to stretch to be 10 meters, right? So all we have to do, we already have this one in meters, we have 10 meters, or sorry, 10 kilometers. So let's get the kilometers into meters. So we have 10 km, and we know that, let's get rid of kms. You could just look at the chart, but I'm doing it this way here just as another way to do it. So 1,000 meters in a kilometer, right? Because kilo is 1,000, so 1,000 meters in a kilometer. So this would be 10,000 meters, which is 1 times 10 to the 1, 2, 3, 4. 1 times 10 to the 4th meters. So we're going 1 times 10 to the 4th meters. Now, 1 times 10 to the 4th meters. Now, how many of those bacteria would it take to get up to 1 times 10 to the 4th? So basically, we're just dividing. You know, we want distance divided by the length of the bacteria. You know, it's like how many lengths of the bacteria here can fit into this distance, right? How many bacteria can fit into that distance? So then we know that we're dividing by the length of the bacteria, and that length of the bacteria is 500 times 10 to the negative 6th. So we're dividing, so we're just subtracting these. So we have 10 to the 4th. 10 to the 4th. So 4 minus negative 6 is 10. So, right, 4 minus negative 6 equals 10. You basically combine those two minuses into a plus. Alright, so we have 1 over 500 times 10 to the 10th. So, you know, if you were to plug this into a calculator or something, you would get, hold on one second, let me do this really quick in a calculator. Alright, so if you were to plug this number here into a calculator, and if you don't know how to do that, you should learn how to do that, you will get 20 million like this. So now we need to convert this. So we have it. We have how many of these bacteria fit into that distance. And we have our number, 20 million. Now, we want to convert this to exponential notation. So that would be 2 times 10 to the, and then we're going to count these zeros. 1, 2, 3, 4, 5, 6, 7. So to move the decimal point here, we need 7. So 2 times 10 to the 7th is going to be our answer, and that is how many amoebas would fit, you know, end to end stretch. So we can write 2 times 10 to the 7th amoebas. And that is our answer. So, it wasn't too bad. You just have to take it one step at a time, and remember that if you're reading a long problem like this, make sure to just take a break and say, oh, 500 micrometers. I know what I need to do to that number. You know, so let's just do that. You know, instead of reading the whole problem and getting confused, just take it one little step at a time. So we have this, 500 times 10 to the 6 meters. Okay, so then we keep going through the problem and find out what else they want us to know. And they want us to know how many of these fit into this distance. So we converted that distance to meters. And then we wanted to know how many of these bacteria, little teeny bacteria, fit into that distance. So we're dividing the big distance by the little one to find out how many little ones fit. And we have our answer, 2 times 10 to the 7th. So that's pretty much it. Thanks for watching. If you have any questions, leave a comment below. Take care.